Okay, so for today's video, we're going to be looking at the arc length of circles. So the arc length. So what we're used to thinking about with these circles is looking at this arc and saying, all right, that's a 60-degree arc, or that's a 45-degree arc with all our circle rules that we learned. What we're actually going to be able to do today is find the actual length or size of this arc, not just in degrees, but we'll actually be able to find a measure that we can assign to it. So how big is AB? Because if I say something's 30 degrees, that's great, but it doesn't really tell me how big it is. It doesn't tell me the size of it. So to do this, to find the arc length, so the actual size of the arc, we're going to use the formula for circumference that we talked about in class. So we're going to use this 2 pi r for this video. All right, so the length of an arc is simply the length of its portion. So this little chunk right here is just part of the whole circumference. So we're going to figure out what portion of the entire circumference these segments or these little arcs are. So how are we going to do this? We're going to set up a proportion. So we'll come back to that part. And to use these formulas, we're going to put them into a proportion that we've kind of been looking at all year. Part over whole equals part over whole. And specifically, today we're going to be just looking at these two, so you don't have to put a box around it because we're going to come back to that sector area. But we're going to be looking at this part. So part over whole, so the angle is to 360. So the part of the circle is to the whole circle, as the part of our circle, the arc length, is to the whole circle or the circumference. So it'll be a little easier to see when we do an example, but this is the formula you're going to use. The angle is to the whole circle, as the arc length is to the whole circumference. So here's our formula, and I have it at the top of the next page as well. So this is what you need to make sure you come out of today, hopefully understanding. The central angle is to 360, or remember our radian measure. Don't forget we have that radian measure as well. The whole circle is 2 pi. So if we have a radian angle measure, we're going to have our full circle in terms of radians. But we'll cross that bridge in a minute when we come to it. So the part of the circle is to the whole circle, as the part of the arc is to the entire full arc all the way around. So here's what it's going to look like. Find the length of arc AB. So we can kind of see this 45-degree angle is a portion of the 360. So the first part of our proportion, we're going to say 45 is to 360. So the part of our circle is to the whole entire thing. And watch how this matches up. It's kind of neat. As the part of our arc right here is to the entire circumference. So you can see how the angle is to 360. This little part is to the full circle here, as the arc length is to the entire circle. So to set this up, we can say 45 is to 360, as our arc length, our unknown, because that's what we're trying to find, right, is to our whole circumference. And the circumference is 2 pi r. So 2 times pi times the radius, which is 12. So we know the angle is to 360, as the arc length is to the entire circumference. So now that we have an equal sign, now we can cross multiply. So we have 360x equals, and I can kind of put this together. I know 2 times 12 is 24. So we're going to keep that pi out of it for now. You'll see what I mean. So equals 24 times 45 times pi. And now it's just some simple algebra. We have 360x equals, and I'll have these calculations done for you. You could obviously just go to your calculator, but equals 1080 pi. And now to get x by itself, we'll just divide both sides by 360. And our final answer, those cancel out. we have x equals, and this comes to exactly 3 pi. So the length of that arc is exactly 3 pi. We could put that into our calculator if we want, and we would get about 9.42. So there's your answer. So it's all about setting up good proportions. All right, so pause it, rewind if you need to watch that again. We'll start on the next one. I'm going to do A and B together, I think. Maybe we'll do A together and see how it goes. So same thing. Now it's telling us we want to find the length of the arc right here, length of arc S. So again, we know that 90 degrees is to this whole circle. So 90 relates to 360 as my arc length here, S, relates to the entire circumference. So it's nice to visualize it that way. So 90 is to 360 is the same relationship as our arc, and I'll keep that as an S, is to our whole circumference. And the circumference here is 2 pi r. The radius here is 16. So I'll do that math all at once. I'll call that 32 pi. But it's always easier to keep the pi out of it to the end. And now we cross multiply. So we have 360s. And 90 times 32, I'll give you that one, is 2,880. Keep the pi out of it. All right, so the math is pretty easy once you get your proportion set up. Now we'll divide both sides by 360. And we get S equals, and this actually comes out a nice even number again, S equals 8 pi. If I say to the nearest tenth or the nearest hundredth, now we'll put it into our calculator, and it comes out to about 25.13 centimeters, because we have centimeters in our problem. Okay, so if it helps you to kind of do those dots like I did, please try that. I'm going to have you do B on your own. So I'm going to pause. You guys can work through it. Use a pencil in case you need to erase. And then when you unpause, I'll have my work there. So go ahead and try it now. All right, so see how you did. This is the key. That's obviously the part that you need to really check to see if you have set up correctly. So take a second. If you need to pause, do that. Once you do that step, we're going to cross multiply, and we actually get a fraction in this case, or a decimal. We get 1.6667 pi. This is when I would go to your calculator and do the math frac button, if you don't have one with you. This would actually turn into 5 pi over 3 centimeters. And that would be our answer there. Okay? So hopefully this makes sense. I think we're going to stop there for now. So your homework is the online homework check. We'll do C and D together in class tomorrow. Those are a little bit different, as you'll discover. So if you want to start thinking ahead a little bit, you can try those out. Otherwise, get your homework done and see you in class.